Hello and a warm welcome to this webinar, How to Save Time and Cost when Migrating to CE 2.0 Grade Services from Veryx Technologies. Let me give you an overview of this webinar. As the communication networks are continuing to evolve, the service providers, you must differentiate yourself from your competition by providing a rapid design and deploying newer services, suitable EPL service or an AVPL service or ELAN, AVP-LAN, E3 to your customers located across the globe. So when you are designing and deploying these services, ensuring that the service is of complete integrity and they are really up to the mark before you turn up, and ensuring that the network downtime is minimum is very critical. You would agree with me in this process that reliability, efficiency, and cost effectiveness is very crucial for the organization such as yours. So as the demand for this Ethernet business services and Ethernet backhaul is on the high, it's very imperative as service providers that you need to employ strategies for migrating to carrier Ethernet 2.0 grade services using standardized approaches. In this webinar, Veryx will be first presenting the various challenges that are typically faced by service providers and carriers in designing and deploying the carrier Ethernet 2.0 services. Once we share the challenges, an overview of Veryx solutions that would help service providers to improve with efficiency by which they can offer CE 2.0 services to the customers will be demonstrated. Before I hand over the platform to Madan, a very brief introduction of Veryx. Veryx is a provider of test and measurement solutions for the communication industry. The company was founded in the year 2002, and over the last 11 years, Veryx has offered automated test solutions for testing requirements in access, carrier Ethernet, data center, and industrial networks. Many of Veryx customers also utilize Veryx test expertise for performing test services based on Veryx and third-party testing products utilizing the ready library from the Veryx test portfolio. Veryx is a leading provider of conformance test solutions for various standards.
We'll now understand few challenges faced by carriers in each of the following phases. Firstly, designing the new CE 2.0 grade services, verifying conformance of the new service with respect to CE 2.0 specifications and having them MEF CE 2.0 certified, ensuring complete integrity of the circuit before service turn-up, and finally troubleshooting. Designing a new CE 2.0 grade service has the following considerations for network architects. The first step, of course, is choosing the right kind of network equipment for each of the network nodes. In this process, more often than not, you end up selecting equipment from different vendors for each of the nodes based on your requirement. So it becomes very important to verify the interoperability of these equipment to deliver a seamless experience to the customer. Next, one needs to benchmark each equipment and each portion of the circuit to ensure that how many simultaneous services of a specific product type that each of these equipment or circuit portions can simultaneously support. For example, how many 30 Mbps bronze services the equipment or a network portion can support simultaneously. You would like to verify whether your existing carrier Ethernet network equipment, which is MEF 9 and MEF 14 certified, is ready to scale up to CE 2.0 before considering any new investments on CE 2.0 certified equipment. Hence, you would typically want a standard test platform to benchmark the equipment that you already have against the CE 2.0 requirements. In this process, one would also like to benchmark the performance of the circuit for various traffic conditions such as varying packet sizes, information rates, and varying burst sizes. Also, you would like to optimize the equipment configurations across nodes to maximize the utilization of the equipment to deliver best possible performance SLAs. One also needs to be able to do a lot of plug and play of equipment from different vendors while designing the service, trying to compare their functionalities and the maximum SLAs that are being achieved in each of these vendor equipments. In summary, there is a lot of effort in planning, evaluating, and designing the new services. After such a detailed design analysis is done in the lab, if you deploy the network, you will have a complete understanding of the capability of each network node and the circuit. Moving on to the next slide. Now, getting more specifically into the MEF conformance from a carrier's perspective, preparation for MEF CE 2.0 conformance starts with understanding the specifications. MEF CE 2.0 is much advanced compared to MEF CE 1.0 in many aspects, such as the new service types like EVP LAN, EP tree, EVP tree, Access EPL, and Access EVPL services that are being defined. Also, there are new concepts such as multiple class of service, color modes, performance parameter measurement methodologies, burst handling requirements, and control frame handling requirements. Control frame handling is applicable to packets such as L2CPs and service OEM frames. Understanding these new concepts is more effective hands-on than just the literature review. You would like to play around with various configurations for each of such requirements and see the end realization of the functionalities. More interesting aspect would be to understand how these functions work together to deliver a seamless end user experience. It would be necessary for carriers to understand and actually benchmark these aspects before presenting their services for MEF certification. Testing in preparation for MEF conformance could be an enormously time-consuming activity when done manually. It would involve testing for numerous CV VLANs and cost labels for specific service VLANs, testing the behavior of L2CP and service OEM frames, and also ensuring that cross VLAN traffic delivery doesn't occur for any of the VLANs. Also, this would require creating multiple different traffic streams for each of these packets, capturing them at the other end, and manually analyzing each of these streams for integrity. All these verifications, if performed manually, would consume significant amount of time. Moving on to the next slide. Once carriers are certified for MEF CE 2.0 and they start selling the services, next phase will be performing service activation tests before actually turning up the services to the customers. Today, most service providers are typically performing RFC 2544 or 1564 verification as part of their service activation testing. However, like the proverbial tip of the iceberg, experience shows that there are a number of other problems that could potentially lie undetected until the customers start using the network. And it would therefore be desirable to determine and remove these potential hidden problems. This becomes all the more critical when you are offering services through multiple partners. For instance, many of you must have observed that the common cause of most customer reported issues point to configuration mismatches resulting in issues relating to VLAN preservation, cost label preservation, burst handling, port security, and control frame handling. This is because RFC 2544 or Y.1564 standards are primarily focused on the performance parameter verifications. However, they do not ensure many of the functional aspects that we'll discuss now. Firstly, VLAN preservation. Let us now quickly see how is the VLAN preservation issue prone to happen. If you see this example, VLAN 10 is the customer VLAN that needs to be preserved end-to-end, that is between UNI and the UNI. But as you can see, the service involves multiple operators. Each operator's network will be subject to handling overlapping VLANs. Hence, the carrier switches are generally configured to stack its own VLAN on top of the customer VLAN. This is done to ensure the traffic separation between customers. So this means that there are multiple configurations across various equipment involved in the end-to-end delivery of the traffic. Also, it involves different set of configurations for upstream and downstream traffic. So if any of these configurations go wrong, then the VLAN will not be preserved. If VLAN is not preserved, then the customer CPE will not accept the frames. Therefore, you can now clearly see that VLAN configuration mismatches can potentially result in erratic loss of traffic for customer, security threat, and potential bandwidth degradation for other customers. Though your initial Y.1564 verification might have passed, testing for VLAN preservation can indicate that the cross VLAN traffic has actually contributed to the 1564 results. So similarly, the cost configuration mismatches can result in potential degradation of service SLAs for the customer, potential SLA misbehavior. For example, voice can get less bandwidth compared to data if cost configuration does not match. Next is port security. Carriers need to ensure the number of MAC addresses allowed on a particular customer port is restricted. If this is not done, the port can learn more MAC addresses on a network equipment and thereby exhausting the MAC table. This could result in potential performance degradation for other customers whose MAC addresses will be restricted from being learned on the equipment. Next, we have bandwidth profile related issues. Carriers often resort to over-provisioning of their circuits to allow more than the agreed CIR, which is committed information rate, or CBS, which is committed burst size, to avoid issues after service turn-up. While this might be beneficial to the customer, it results in underutilizing of the network equipment. For example, over-provisioning might restrict an equipment which could have supported 100 services to support only 80 services. Next, we have frame handling related issues. For seamless delivery of the service, it is important to ensure the control packets such as L2CPs or the service OEM frames are appropriately handled. For example, the improper handling of a service OEM frame can result in false alarms raised by fault management systems. To give a specific scenario, suppose if the service is configured to tunnel service OEM frames, but in reality if the circuit doesn't tunnel the service OEM frames, then the subscriber may which is monitoring the service, would detect a fault and raise alarms. However, this is a false alarm that is being raised, even when there is no fault in the service. This could result in unnecessary effort towards troubleshooting the cause. And finally, when it comes to troubleshooting, it could be a time-consuming activity in isolating CVLAN or cause that is not preserved end-to-end, or the MAC address that is not being handled properly. Even though the initial configuration would have verified all these aspects during service turnup, there are chances that these configurations get overwritten during subsequent service configurations. So a quick verification of these aspects should be possible to ensure that you reduce the network downtime. Often during troubleshooting, you would want to quickly verify whether VLAN traffics are crossing each other. This is done to ensure that you're troubleshooting for the right traffic. Also, in case of performance issues, specifically relating to burst, it could be a challenging task to isolate the exact burst sequence or timing which is creating an issue. You would require a standard aligned tool in order to accurately compare the behavior against a standard benchmark whenever customer reports such an issue. And most importantly, performing such troubleshooting by deploying field technicians could be significantly time consuming. So there needs to be a way to perform such troubleshooting from a centralized location. So briefly, I have covered many of the challenges that service providers face today in migrating to Carrier Ethernet 2.0. That overcoming these challenges could be significantly time consuming and thereby escalating the operational costs.
Now we shall cover how Veryx solution can help overcome the challenges discussed so far. There are two solutions that Veryx provides. Veryx SAMTEST solution is designed to help carriers in verifying device interoperability, benchmarking the equipment and circuit for performance and scalability, performing quick and comprehensive service activation tests before service turnup, and quickly troubleshooting to reduce the network downtime. Whereas Veryx Attest solution is designed to test for MEF CE 2.0 conformance towards preparation for MEF CE 2.0 certification by MEF authorized test agency. Moving on to next slide. Now I'll explain the highlights of SAMTEST and go on to a live demonstration. As I said, Veryx SAMTEST can be used in the lab environment during service design and also in the field during service turnup and troubleshooting. SAMTEST pre-built tests cover MEF CE 2.0 tests tuned to meet service activation testing and Y.1564 verification. The platform is flexible for customization of existing tests and addition of new tests. In the field environment, SAMTEST has a centralized controller that connects with Veryx test probes, executes the test, and captures the results. The tests are performed either using data or service OEM loopback messages. SAMTEST comes in two different variants. Variant 1, where testing can be performed using test probes at both the ends. It can be between uni and a uni or uni and a ANNI. In the case of a Ethernet wholesale, where the service provider do not get access to access provider network equipment, many service providers use this variant. Also, the test coverage is more comprehensive to include all of the CE 2.0 requirements as part of service turn-up. This is because typically in case of wholesale, you'd want to ensure maximum integrity before turn-up. Otherwise, troubleshooting a live circuit involving multiple operators could be significantly time-consuming. Variant 2 can perform testing using test probes at a suitable aggregation point and looping back the traffic from third-party Ethernet access devices. Typically, this is used in cases where service providers want to optimize the time taken to ship the test probes to the access network. Moving on to next slide. The chart you see on the screen lists the matrix of test coverage across the variants. The differences lie mainly in performance measurements. Using test probes on both ends, one can perform one-way measurements. However, in the niche scenario, the performance values are derived from two-way measurements. Other differences are with respect to CBS enforcements and verifications for untagged and priority tagged frames. Moving on to next slide. SAMTEST also be used in lab environment where the endpoints of the circuit can be connected to the Veryx test probe. SAMTEST controller in turn connects to the test probes and initiates the test. The tests are performed using data frames in the lab environment. Now we'll give you a brief demonstration of Veryx SAMTEST. I hope you can see the SAMTEST screen. Tests in SAMTEST can be viewed by clicking on the Profiles button. The test library you see on the screen is classified based on service type and the test method. We have three types. The first one, CU 2.0 functionality test using data frames. CU 2.0 functionality test using service OEM loopback frames. And finally, the Y1564 test. These three types are applicable each of the service types. For example, you see on the screen library for EAS and library for E-line. The user can also create custom profiles based on the pre-built test. Each library has pre-built test profiles. The tests are further classified into activation tests and diagnostic tests. The activation test covers CE 2.0 attribute verification and performance tests. As you can see on the screen, each of the functionality tests such as VLAN preservation, cost preservation, MTU, MAC and port security, information rate and burst size tests are grouped appropriately. SAMTEST tests are automated, so they save a lot of time and effort in running the test, especially when they have to be repeated. Although they are automated, users have a great level of control in performing the test. Often tests that takes days or weeks can be completed in a few hours. That is a huge saving. The workflow in SAMTEST starts with creating a database of products offered by the service provider. When customer orders a service, the details about the customers must be keyed in under customers. Then the customer can be associated with a product by creating a circuit and specifying the circuit detail such as SVLAN and CVLAN. Before starting the test execution, the details of the test probes or NIDs must be configured in the controller. This can be done by clicking the probes button or the NIDs button under the assets and specifying the details. Once the test probes or NIDs are configured, tests can be started by clicking the execute and selecting the circuit to be tested. You must specify the probe ports that you want to use for testing. And select an existing test profile and specify the test duration parameters. The user can modify the test profile or create a new test profile before initiating the test. During the test execution, you can use the live chart utility to monitor the traffic rate and frame delay variation. The green line in the chart indicates the transmit rate and the red represents the receive rate. To move on to how SAMTEST aids in failure analysis, let us take a look at a failed log. In case of a failure, the test log provides information about failure cause step by step. In this example of a CVLAN preservation test failure, the log shows the comparison between the expected frame content and the received frame content. It also provides an illustration by providing the frame difference. The one on the left is the expected frame content and the one on the right is the received frame content. And the difference is clearly highlighted by means of a red band. Similarly, each test log provides appropriate information to aid easy analysis. So the user knows what the issue is and can zero down very quickly. A failed test would also point to the relevant diagnostic test to be performed for further analysis. In case of a bandwidth profile test failure, the log that you are looking currently on your screen shows a mismatch in the expected versus received frame count. SAMTEST displays a detailed report of the circuit in a birth certificate format, which can be exported to PDF and published to the customer and other stakeholders. The report also shows the values of performance parameters along with graphical charts for easy comprehension of results. So that was the brief on the SAMTEST and the SAMTEST demonstration. We'll now move on to a brief overview of ATTEST followed by ATTEST demo. Veryx ATTEST solution is designed for MEF CE 2.0 conformance and maps one-on-one to the MEF CE 2.0 test plan. So carriers can be certain that they are meeting MEF conformance requirements. Veryx ATTEST solution is also valuable for ongoing tests that need to be performed from time to time to ensure that the services are conforming to CE 2.0 when you change or add more network elements. Similar to SAMTEST, ATTEST can also be used in both lab and field environment. ATTEST tests map directly to MEF CE 2.0 test plan, and all the tests can be executed in an automated fashion. Now let's move on to ATTEST demo. The GUI you see on the screen is the ATTEST user interface. Test cases can be accessed from the test case manager. The test suites available are listed in the catalog pane. There is a test suite for e-access, e-LAN, e-line, and e-tree service type. Expanding the tree structure provides you or displays the groups and subgroups followed by the test cases. Selecting a test will display the information about the test, such as the test objective or test purpose, reference in the standard or specification, test topology, configuration, and the test procedure. ATTEST also provides you with reports for the tests that are executed. These reports can be viewed from Test Progress Manager. The report gives you a summary of the tests that passed, failed, and inconclusive. These reports can be exported as PDF and CSV. Further information about a specific test behavior can be obtained from the test log. There is also a packet sequence display which displays the packets exchanged between the test probe and the device or circuit under test. So that ends the brief demo on ATTEST.
This presentation really highlighted many of the service provider challenges and the kind of a standardized approach that when a service provider follow would help overcome these challenges. I think certainly overcoming many of these issues in the service design and during service turn-up would certainly substantially reduce the operational expenditure and also in maintaining and troubleshooting the networks after they are turned up. And most importantly, that from Veryx side we emphasize is an organized approach would help in developing your loyal customer base. So I take this opportunity to once again thank all the participants who took your time to join us. If you have any questions, any further clarification, please feel free to email to those speakers' email addresses which were shared in the earlier part of the presentation. Thank you once again and have a good day. Bye-bye.